So topic 14, organic chemistry, and the subtopic is alkanes. What is the meaning of alkane? Alkane means between the two carbon atoms throughout the chain we will find a single bond. So if there's a single bond between the carbon atoms throughout the chain, we call them as alkane. So if you want to name these alkanes, how to name? Example, one carbon and there are four hydrogen. So what will be the name of this compound? Because there is one carbon. Due to one carbon atom, what is the prefix we use? The prefix, the starting name will be meth. Meth is when one carbon. And because they have a single bond, so we will call that as ane. So it is methane. Same way, if we have two carbon atoms, how many hydrogen will be there on the left hand side carbon? These are hydrocarbons, so how many hydrogen will be there on the left hand side? Carbon maximum can form 4 bonds, so this will have 3 hydrogen. And how many hydrogen on the right hand side? That's also 3. So 3 hydrogen on the left and 3 hydrogen on the right. But how to name a compound? Naming a compound depends on the number of the carbon atoms. Because 2 carbon atoms are there, that's why we call eth. Due to the presence of a single bond between the carbon atoms, what we call that as ane. So it is ethane. Same way, if we have 3 carbon atoms, how many hydrogen the carbon on the left hand side will have? How many hydrogen? So 3, because carbon maximum can form 4 bonds, so it will have 3. How many hydrogen atoms are there attached with the central carbon atom? And how many hydrogen atoms are attached to the last on the right hand side carbon? Carbon maximum can form 4 bonds. So because one is already formed, so remaining 3 hydrogen. And we call them as a hydrocarbon because it contains carbon and hydrogen. Then what is the name of this compound? 3 carbon atoms. So for 3 carbon atoms, the name should start with prop. Prop means 3 carbon atoms. And because these carbon atoms have a single bond between them, so it will be ane. So it is propane. Prop means 3 carbon and ane because they have single bond. Then for 4 carbon atoms, 1, 2, 3 and 4, how many hydrogen the left hand side carbon will have? 3. How many hydrogen the second 2? How many hydrogen on the right hand side? 2. And how many hydrogen on the last one? That is 3. Yeah, that's right. So CH3, CH2, CH2 and CH3. Now, what is the name of the compound? Because 4 carbon atoms are there. Whenever you have 4 carbon atoms, we call but. And because they have a single bond between them, so we'll call them as ane. So it is butane, A-N-E. So but because of 4 carbon and A-N-E, and because of single bond. So these are some alkanes: methane, ethane, propane and butane. So in this topic, we'll discuss all about alkanes. First thing, they have a general formula of CnH2n plus 2. Means if I want to find any alkane, I can use this formula and I'll get the answer. I'll get the molecular formula. Like example, if I say what is a formula for pentane. So what is the meaning of pent? The term pent means 5. So what is the value of n? N is equals to 5. So we substitute in this formula, we substitute 5. So it will be C5H 2 multiplied by 5 plus 2. So 5 multiplied by 2, 10 plus 2, 12. So it will be C5NH12. That is a formula for pentane. Same way, if I want to find the formula for butane. So but, the term but means how many carbon? What is the value of N? The term but means how many carbon? So but means 4 carbon. So N is equals to 4. So we will put N is equals to 4 in the formula, which is CnH2n plus 2. So C4H 2 multiplied by 4 plus 2. So it will be C4 2 multiplied by 4 is 8 plus 2 10. So C4H10. So C4H10 is a formula for butane. Same way, if I want to find a formula for propane. So the term prop means what? The term prop means N is equals to 3. So we'll put C3 H2 multiplied by 3 plus 2. So C3 2 multiplied by 3 6 plus 2, so it will be 8. C3 and H8, so that will be propane. So for all these alkanes we can get them by using a general formula CnH2n plus 2. Because of the carbon-carbon single bond, what we call them as ane. The name should end at ane. And they are called saturated hydrocarbons. So another name for alkane, what is the name of another name for alkane? Alkanes are also known as saturated hydrocarbon. Saturated hydrocarbon means between the carbon atom there is a single bond. And they react by substitution. What is the meaning of substitution? The term substitution means one atom or group of atoms will replace the other atom or group of atoms. Like example, I have CH4 and it reacted with chlorine, Cl2. So what is the meaning of substitute? And as in a soccer or a football, you have seen when one player enters the field, the other player leaves. So out of 2 chlorine, 1 chlorine will enter and 1 hydrogen will leave. That's why we call that as a substitution. One atom enter, another atom leave. So what will be the product when one hydrogen leave and 1 chlorine enter? So the product which is formed here will be CH3Cl. Why CH3Cl? Because 1 hydrogen leave, 1 chlorine enter. Plus out of 2 chlorine, 1 chlorine is left and hydrogen enters, so it will form HCl. And this reaction is refers to substitution reaction. Like another example for the substitution reaction of alkanes. So substitution reaction of alkane, what does it mean? It means one will enter, the other will leave. So if I have C2H6 and we add chlorine, like react with chlorine, what will be the product? A substitution reaction occur, means one hydrogen will go out and 1 chlorine will enter. So what will be the product? It will be C2. Out of 6 hydrogen, we are left with 5 hydrogen, so C2H5. And 1 chlorine enters, so it will become C2H5Cl plus HCl. And another substitution like this can further undergo a substitution reaction. If we have C2H5Cl and it reacted with another chlorine molecule. So every time 1 hydrogen will go out and 1 chlorine will enter. So what will be the product here? Because initially there were 5 in the beginning, at the start 5 hydrogen, but now it will be 4 hydrogen. So C2H4. And first 1 chlorine was there, but another entered. So it becomes Cl2 plus HCl. So always remember, one chlorine enter, the other hydrogen leave. And we call this type of reaction as a substitution reaction. Is it clear, the concept of substitution? So whenever any alkane is there, it does not depend on which alkane. If you have any alkane, always this happens that one hydrogen leave, another chlorine will and take position. So example C3H6 or C3H8. So you have C3 and H8 and it reacted with Cl2. Cl2 means chlorine molecule, and if it is alone Cl, it means chlorine atom. One means atom, two means molecule. Now, what happened? A substitution reaction. 8 hydrogen and 2 chlorine. Out of 8, one of the hydrogen will go out. And out of 2, one of the chlorine will enter. So what will be the product here? Carbon number does not change. So 3 carbon will remain 3. 8 hydrogen first. Out of 8, 1 will go out. So how many we are left with? 7. And out of 2 chlorine, like Cl2 means chlorine molecule. So from chlorine molecule, 1 chlorine atom enter. So it becomes Cl. Plus, what else will be the product? And hydrogen combined with Cl, so it will produce HCl. So this is one of the product. Then this one C3H7Cl can further react. So this is C3H7Cl plus another chlorine. Now what could be the product? Again, same thing happened. We have now 7 hydrogen. So out of 7 hydrogen, 1 hydrogen enter. And out of 2 chlorine, substitution reaction occur. So what will be the product? The carbon number does not change. So it will remain C3. How many hydrogen? Out of 7, 1 is going out. So it will become H6. And first there was 1 chlorine, but another chlorine entered. So it will become Cl2. Like 2 chlorine atoms are now attached with this structure. Plus HCl. Is it clear? So always remember, whenever alkanes react with chlorine, they will undergo substitution reaction. And it is valid for any alkane. So if we have C7NH16 plus Cl2, can you state a product? What will be the product when they react with each other? What will be the final product of substitution? The carbon number does not change. So C7, because carbon number does not change, so C7. Out of 16, originally we were having 16 hydrogen. Now we'll have 15 hydrogen. And 1 chlorine enters, so it becomes Cl plus HCl. And this C7, if this further reacted, C7H15Cl reacted with another chlorine molecule. So what will be the product? Out of 15, 1 will enter, and here 1 will enter and 1 will leave. So the final product will be C7 H14 Cl2 plus HCl. So this will always be a product. You have to learn a reaction condition. What are the conditions for this reaction? At what condition this reaction will occur? You have to memorize this. The conditions, it should be done at a high temperature and in the presence of ultraviolet light or UV. The light which is having a frequency more than the visible light, that's called ultraviolet or UV. So in the presence of ultraviolet radiation, this reaction can proceed. So alkanes undergo a substitution reaction. Then first four members of these alkane are gases. Like what are the first four members? We have methane, ethane, propane, and butane. These members, the first four members are what? They are existing as a gas. Then after butane, we have pentane. So that will be liquid. And higher alkanes are wax-like solid. Wax-like solid means that it does like not very hard solid. It is a can be deformed easily. So they are wax-like solid. As the number of the carbon increase, the boiling point will also increase. The density also increase and energy which is given off will also increase. So example, if we have alkane, methane is there, CH4, we have ethane, C2, H6, we have propane, which is C3 and H8, and we have butane, C4 and H10. Which one you think will have the high boiling point? The boiling point increases as the number of the carbon increase. Greater the number of the carbon, higher the boiling point. So which one you think will have the highest boiling point in these four? So boiling point is directly proportional to number of the carbon. More carbon atoms, higher boiling point. So C in this series C4 and H10 will have a high boiling point and CH4 will have a low boiling point. And boiling point and volatility here refers to the property to convert into vapor or easily vaporize. That's called volatile. So remember, boiling point and volatility are inversely proportional. The term volatile means easily vaporized. So if the substance is having a high boiling point, it will be less volatile. If a substance is having a low boiling point, it will be more volatile. Volatile means easily convert into vapor. So when we compare C4H10, it will have a high boiling point, but it will have low volatility. Like it cannot be easily converted into vapor. But CH4, it's having a low boiling point, so it will have high volatility. So volatility and the boiling points are inversely proportional. And these alkane does not dissolve in water, so they are insoluble in water. Then the reactions of alkane, number one is a combustion and number two is substitution. So combustion means burning. Combustion of alkanes. Alkanes can be complete combustion and they might have incomplete combustion. Combustion here refers to burning. So whenever we burn alkanes, the complete combustion gives carbon dioxide and water. So alkane plus oxygen and the reaction is exothermic. It releases energy. give carbon dioxide plus water. That is the complete combustion. But incomplete combustion, if alkane not burned completely, what will be the result? So alkane plus carbon oxygen gives carbon monoxide, which can cause suffocation, plus water will be there. So in exam, you have to check whether they mention it's a complete combustion or incomplete combustion. So with reference to the question, you have to state a product. If it's a complete combustion, then carbon dioxide. If it's an incomplete combustion, then carbon monoxide will be there. So if I say we burn CH4 and it's a complete combustion, CH4 plus O2, and there's a complete combustion, what will be the product if we burn CH4 completely? So if we burn completely, then the product will be carbon dioxide, CO2 plus water, H2O. And for balancing the equation, because first thing is completing the equation, second is balancing. So when you try to balance the combustion equation, you start with oxygen, you start with carbon. The combustion equation, you start with carbon, followed by hydrogen, and at the last, oxygen. So when we try to balance carbon, there is one carbon on the left and there is one carbon on the right, so carbon is balanced. When we check hydrogen, 4 hydrogen on the left and 2 hydrogen on the right. So to make it 4, we put 2 here. So hydrogen is also balanced. Now oxygen, 2 oxygen on the left and 4 oxygen, because 2 plus 2, 4. So we want to make 4 oxygen. So we put 2, oxygen is also balanced. So whenever you are trying to balance a combustion equation, balance with carbon, followed by hydrogen, and at the last, oxygen. So if you want to balance any, the mostly complete combustion questions are there. So if you want to balance or write a balance equation for C2H6, we are burning ethane. Most of them are used as a fuel, and we can use them as a fuel by burning, combustion, which is also an addition of oxygen. So oxidation you can also refer. If a complete combustion is there, what will be the product? If we burn C2H6 completely, what will be the product of combustion? A complete combustion of C2H6 hydrocarbon. What will be the product? So because it's a complete combustion, so product is carbon dioxide and water. So CO2 plus H2O. Then for balancing, start with carbon, as I mentioned in the beginning, start with carbon, followed by hydrogen, and at the last, oxygen. So we have 2 carbon on the left, we should have 2 carbon, so we put 2, carbon is balanced. Then hydrogen, 6 hydrogen on the left and 2 hydrogen on the right, so we put 3, hydrogen is also balanced. Now what about oxygen? 2 multiplied by 2, 4 plus 3, 7 oxygen on the right hand side. And there is only 2 oxygen on the left. So we have to balance oxygen now, but how we can make this 2 oxygen into 7, like making an odd number? So if I multiply by 3.5, because 3.5 multiplied by 2, that will become 7. So 3.5 into 2 will make it 7. So now it becomes 7 on the left and 7 on the right. But for balancing, we use whole number. So what you will do, if you have to use a decimal to balance this equation, you will multiply all of them by 2. So when I multiply all of them by 2, what it become? This will become 2 C2H6. This 3.5 multiplied by 2, it become 7O2. This 2 multiplied by 2 become 4 CO2. And this 2 multiplied by 3 become 6H2O. So this equation is balanced in terms of carbon, hydrogen and oxygen. So what we did, first we balance carbon by putting 2, then we balance hydrogen and at the last oxygen. But to balance oxygen, we cannot use a whole number. We should use a fraction or a decimal number to balance oxygen, which is 3.5. Because 7 oxygen on the right, so there should be 7 oxygen on the left. So I put 3.5. But normally we don't use decimal to balance the equation. So how to change the decimal into a whole number? Then you will multiply all the equation by 2. So when you multiply whole equation by 2, it will become 2 before the C2H6. Then this 3.5 will become 7. And this 2 carbon dioxide will become 4. And this 3 water will become 6. So this is the equation which is balanced in terms of all of this carbon, hydrogen and oxygen. Is it clear, this example? So whenever we want to use a decimal to balance the equation, we always multiply the equation by 2. Example, I have C3 and H8 plus O2. So what will be the product C3H8 if complete combustion give carbon dioxide plus water? Now to balance this equation, three carbon. So first we start with carbon followed by hydrogen and then oxygen. So 3 carbon, so we put 3 carbon is balanced. Then 8 hydrogen, so we put 4 hydrogen is also balanced. Now about oxygen, 3 multiplied by 2, 6 oxygen, and this is 4. So 4 plus 6, 10 oxygen. We need total 10 oxygen atoms, so we should have 10. In this case, we put 5. 5 multiplied by 2 become 10. So this equation, we don't have to multiply by 2 because we are using a whole number to balance oxygen. So whenever we are using a whole number to balance oxygen, we don't have to multiply by 2. But what if the equation was other way around, like another compound was there, say we have C4 and H10 reacted with oxygen O2. It gives carbon dioxide CO2 plus water H2O. Now for balancing 4 carbon, so we need 4 because we start with carbon followed by hydrogen at the last oxygen. So 4 carbon, so we should put 4, carbon is balanced. 10 hydrogen, so we put 5, so hydrogen is balanced. Now what about oxygen? 4 multiplied by 2, 8 oxygen here and 5, 8 plus 5, total 13 oxygen. So we need 13. What number I should multiply with 2 to get 13? Which number should be multiplied by 2 to get 13? So the number should be multiplied by 2 to get 13, that is 6.5. So because 6.5 multiplied by 2 will give us 13. But again the problem, we cannot use a decimal here to balance. So what we will do, we'll multiply the whole equation by 2. So when we multiply the whole equation by 2, so this is the equation C4 H10 O2. This was the original equation. When we try to balance with the decimal for oxygen, we'll multiply whole equation by 2. So here 2 multiplied by this number is 1, so it will remain 2. 2 multiplied by 6.5, so it becomes 13. 2 multiplied by 4, so it becomes 8. And 2 multiplied by 5, so it becomes 10. So this equation is balanced in terms of carbon, hydrogen and oxygen. Is it clear, this example, how to balance equation for combustion of alkane? Then drawing the isomers of alkane. Isomer means they will have the same molecular formula, but different structures. We call them as isomer. So whenever we want to draw an isomer of alkane, what we'll do, we'll make a straight chain and then we'll make branches. First one, we'll draw a straight chain. And then we will draw the branched. So how to draw an isomer? Like example, if I say you want to draw an isomer of alkane, which is C4NH10. Draw two isomers of C4H10. So isomer means different structure but same number of atoms. So 4 carbon atoms, first draw them in a straight chain and then put hydrogen. The first one will have 3 hydrogen. The second one will have 2 hydrogen. The third one will also have 2 hydrogen and the last one will have 3 hydrogen. So this is 1. Then isomer of the branched one. So 1, 2 and 3 we draw in a straight line. And branch you cannot put with the first one, it is always with the second, like in between, either up or down, it does not make difference. Then we put hydrogen atoms. This will have 3 hydrogen, this will have 1 hydrogen, this will have 3 hydrogen, and the top one will also have 3 hydrogen. So you can see they have the same molecular formula. When I count the number of the carbon atoms, C4 and number of hydrogen atom 10. This is also C4H10. So same molecular formulas. The two compounds have the same molecular formula, but they have different structure. So we call them as isomers. So whenever you want to draw an isomer of alkane, we make one as a straight chain, another one as a branched. Is it clear? We did this part in the last session, that how to draw an isomer. We just break the structure, one as an inline and one as a branch. We call them as isomer because they have different structures as they have the same molecular formula. So this was about alkanes. About alkanes, you have to learn that the journal formula for alkanes, the name, how to name alkanes, how to draw different isomers, as well as the two reactions. One is combustion, burning, another one is substitution. Any question related to this alkanes?